Hello everyone, this is Atul from Edureka and welcome to today's session on what is machine learning. As you know, we are living in a world of humans and machines. The humans have been evolving and learning from the past experience since millions of years. On the other hand, the era of machines and robots have just begun. In today's world, these machines or the robots are like they need to be programmed before they actually follow your instructions. But what if the machines started to learn on their own? And this is where machine learning comes into picture. Machine learning is the core of many futuristic technological advancement in our world. Today you can see various examples or implementation of machine learning around us, such as Tesla's self-driving car, Apple Siri, Sophia AI robot, and many more are there. So what exactly is machine learning? Well, machine learning is a subfield of artificial intelligence that focuses on the design of system that can learn from and make decisions and predictions based on the experience, which is data in the case of machines. Machine learning enables computer to act and make data-driven decisions rather than being explicitly programmed to carry out a certain task. These programs are designed to learn and improve over time when exposed to new data. Let's move on and discuss one of the biggest confusion of the people in the world. They think that all the three of them, the AI, the machine learning, and the deep learning, all are same. You know what? They are wrong. Let me clarify things for you. Artificial intelligence is a broader concept of machines being able to carry out tasks in a smarter way. It covers anything which enables the computer to behave like humans. Think of a famous Turing test to determine whether a computer is capable of thinking like a human being or not. If you're talking to Siri on your phone and you get an answer, you're already very close to it. So this was about the artificial intelligence. Now coming to the machine learning part. So as I already said, machine learning is a subset or a current application of AI. It is based on the idea that we should be able to give machine the access to data and let them learn from themselves. It's a subset of artificial intelligence that deals with the extraction of pattern from dataset. This means that the machine can not only find the rules for optimal behavior, but also can adapt to the changes in the world. Many of the algorithms involved have been known for decades, centuries even. Thanks to the advances in the computer science and parallel computing, they can now scale up to massive data volumes. So this was about the machine learning part. Now coming over to deep learning. Deep learning is a subset of machine learning where similar machine learning algorithms are used to train deep neural networks so as to achieve better accuracy in those cases where former was not performing up to the mark. Right. I hope now you understood that machine learning, AI, and deep learning, all three are different. Okay, moving on ahead. Let's see, in general, how a machine learning works. One of the approaches is where the machine learning algorithm is trained using a labeled or unlabeled training dataset to produce a model. New input data is introduced to the machine learning algorithm and it makes prediction based on the model. The prediction is evaluated for accuracy, and if the accuracy is acceptable, the machine learning algorithm is deployed. Now, if the accuracy is not acceptable, the machine learning algorithm is trained again and again with an augmented training dataset. This was just a high level example, as there are many more factors and other steps involved in it. Now let's move on and subcategorize the machine learning into three different types: the supervised learning, unsupervised learning, and reinforcement learning. And let's see what each of them are, how they work, and how each of them is used in the field of banking, healthcare, retail, and other domains. Don't worry, I'll make sure that I use enough examples and implementation of all three of them to give you a proper understanding of it. So starting with supervised learning. What is it? So let's see a mathematical definition of supervised learning. Supervised learning is where you have input variables x and an output variable y, and you use an algorithm to learn the mapping function from the input to the output, that is y equal fx. The goal is to approximate the mapping function so well that whenever you have a new input data x, you could predict the output variable, that is y, for that data. Right. I think this was confusing for you. Let me simplify the definition of supervised learning. So we can rephrase the understanding of the mathematical definition as a machine learning method where each instances of a training dataset is composed of different input attribute and an expected output. The input attributes of a training dataset can be of any kind of data. It can be a pixel of image, it can be a value of a database row, or it can even be an audio frequency histogram, right? For each input instance, an expected output value is associated. The value can be discrete, representing a category, or can be a real or continuous value. In either case, the algorithm learns the input pattern that generate the expected output. Now, once the algorithm is trained, it can be used to predict the correct output of a never seen input. You can see an image on your screen, right? In this image, you can see that we are feeding raw inputs as image of apple to the algorithm. As a part of the algorithm, we have a supervisor who keeps on correcting the machine or who keeps on training the machine. It keeps on telling him that yes, it is an apple and no, it is not an apple. Things like that. So this process keeps on repeating until we get a final trained model. Once the model is ready, it can easily predict the correct output of a never seen input. In this slide, you can see that we are giving an image of a green apple to the machine, and the machine can easily identify it as yes, it is an apple and it is giving the correct result. Right. Let me make things more clearer to you. Let's discuss another example of it. So in this slide, the image shows an example of a supervised learning process used to produce a model which is capable of recognizing the ducks in the image. The training dataset is composed of labeled picture of ducks and non-ducks. The result of supervised learning process is a predictive model which is capable of associating a label duck or not duck to the new image presented to the model. Now once trained, the resulting predictive model can be deployed to the production environment. You can say a mobile app for example. Once deployed, it is ready to recognize the new pictures. Right. Now you might be wondering why this category of machine learning is named as supervised learning. Well, it is called as supervised learning because the process of an algorithm learning from the training dataset can be thought of as a teacher supervising the learning process. We know the correct answers. The algorithm iteratively makes while predicting on the training data and is corrected by the teacher. The learning stops when the algorithm achieves an acceptable level of performance. Now let's move on and see some of the popular supervised learning algorithms. So we have linear regression, random forest, and support vector machines. These are just for your information. We'll discuss about these algorithms in our next video. Now let's see some of the popular use cases of supervised learning. So we have Cortana. Cortana or any other speech automation in your mobile phone trains using your voice. And once trained, it starts working based on that training. This is an application of supervised learning. Suppose you are telling, okay, Google, call Sam, or you say, hey Siri, call Sam. You get an answer to it, and the action is performed, and automatically a call goes to Sam. So these are just an example of supervised learning. Next comes the weather app. Based on some of the prior knowledge, like when it is sunny, the temperature is higher. When it is cloudy, humidity is higher. Any kind of that, they predict the parameters for a given time. So this is also an example of supervised learning as we are feeding the data to the machine and telling that whenever it is sunny, the temperature should be higher. Whenever it is cloudy, the humidity should be higher. So it's an example of supervised learning. Another example is biometric attendance, where you train the machine and after a couple of inputs of your biometric identity, be it your thumb, your iris, or your earlobe, or anything, once trained, the machine can validate your future input and can identify you. Next comes in the field of banking sector. In banking sector, supervised learning is used to predict the credit worthiness of a credit card holder by building a machine learning model to look for faulty attributes by providing it with a data on delinquent and non-delinquent customers. Next comes the healthcare sector. In the healthcare sector, it is used to predict the patient's readmission rates by building a regression model by providing data on the patient's treatment administration and readmissions to show variables that best correlate with readmission. Next comes the retail sector. In retail sector, it is used to analyze the product that a customer buy together. It does this by building a supervised model to identify frequent item sets and association rule from the transactional data. Now let's learn about the next category of machine learning, the unsupervised part. Mathematically, unsupervised learning is where you only have input data X and no corresponding output variable. The goal for unsupervised learning is to model the underlying structure or distribution in the data in order to learn more about the data. So let me rephrase you this in simple terms. In unsupervised learning approach, the data instances of a training dataset do not have an expected output associated to them. Instead, unsupervised learning algorithm detects pattern based on innate characteristics of the input data. An example of machine learning task that applies unsupervised learning is clustering. In this task, similar data instances are grouped together in order to identify clusters of data. In this slide, you can see that initially we have different varieties of fruits as input. Now these set of fruits as input X are given to the model. Now, once the model is trained using unsupervised learning algorithm, the model will create clusters on the basis of its training. It will group the similar fruits and make their cluster. Let me make things more clearer to you. Let's take another example of it. So in this slide, the image below shows an example of unsupervised learning process. This algorithm processes an unlabeled training dataset, and based on the characteristics, it groups the picture into three different clusters of data. Despite the ability of grouping similar data into clusters, the algorithm is not capable to add labels to the group. The algorithm only knows which data instances are similar, but it cannot identify the meaning of this group. So now you might be wondering why this category of machine learning is named as unsupervised learning. So these are called as unsupervised learning because unlike supervised learning, above there are no correct answers and there is no teacher. Algorithms are left on their own to discover and present the interesting structure in the data. Let's move on and see some of the popular unsupervised learning algorithm. So we have here k-means, a priori algorithm, and hierarchical clustering. Again, these are just for your information's sake. We'll discuss about these algorithms in our next video. Now let's move on and see some of the examples of unsupervised learning. Suppose a friend invites you to his party and where you meet totally strangers. Now you'll classify them using unsupervised learning as you don't have any prior knowledge about them. And this classification can be done on the basis of gender, age group, dressing, educational qualification, or whatever way you might like. Now, why this learning is different from supervised learning? Since you didn't use any past or prior knowledge about the people, you kept on classifying them on the go. As they kept on coming, you kept on classifying them. Yeah, this category of people belong to this group, this category of people belong to that group, and so on. Okay, let's see one more example. Let's suppose you have never seen a football match before, and by chance you watch a video on the internet. Now you can easily classify the players on the basis of different criterion. Like player wearing the same kind of jersey are in one class, player wearing a different kind of jersey are in different class. Or you can classify them on the basis of their playing style, like the guy is an attacker, so he's in one class. He's a defender, he's in another class. Or you can classify them whatever way you observe the things. So this was also an example of unsupervised learning. Let's move on and see how unsupervised learning is used in the sectors of banking, healthcare, and retail. So starting with banking sector. So in banking sector, it is used to segment customers by behavioral characteristic by surveying prospects and customers to develop multiple segments using clustering. In healthcare sector, it is used to categorize the MRI data by normal or abnormal images. It uses deep learning techniques to build a model that learns from different features of images to recognize a different pattern. Next is the retail sector. In retail sector, it is used to recommend the products to customer based on their past purchases. It does this by building a collaborative filtering model based on the past purchases by them. I assume you guys now have a proper idea of what unsupervised learning means. If you have any slightest doubt, don't hesitate and add your doubt to the comment section. So let's discuss the third and the last type of machine learning, that is reinforcement learning. So what is reinforcement learning? Well, reinforcement learning is a type of machine learning algorithm which allows software agents and machine to automatically determine the ideal behavior within a specific context to maximize its performance. The reinforcement learning is about interaction between two elements, the environment and the learning agent. The learning agent leverages two mechanisms, namely exploration and exploitation. When learning agent acts on trial and error basis, it is termed as exploration. And when it acts based on the knowledge gained from the environment, it is referred to as exploitation. Now, this environment rewards the agent for correct actions, which is reinforcement signal. Leveraging the rewards obtained, the agent improves its environment knowledge to select the next action. In this image, you can see that the machine is confused whether it is an apple or it's not an apple. Then the machine is trained using reinforcement learning. If it makes correct decision, it gets rewards point for it. And in case of wrong, it gets a penalty for that. Once the training is done, now the machine can easily identify which one of them is an apple. Let's see an example. Here we can see that we have an agent who has to judge from the environment to find out which of the two is a duck. The first task he did is to observe the environment. Next, he selects some action using some policy. It seems that the machine has made a wrong decision by choosing a bunny as a duck. So the machine will get penalty for it. For example, minus 50 point for a wrong answer. Right. Now the machine will update its policy and this will continue till the machine gets an optimal policy. From the next time, machine will know that bunny is not a duck. Let's see some of the use cases of reinforcement learning. But before that, let's see how Pavlov trained his dog using reinforcement learning, or how he applied the reinforcement method to train his dog. Pavlov integrated learning in 4 stages. Initially, Pavlov gave meat to his dog, and in response to the meat, the dog started salivating. Next, what he did, he created a sound with the bell. For this, the dog did not respond anything. In the third part, he tried to condition the dog by using the bell and then giving him the food. Seeing the food, the dog started salivating. Eventually, a situation came when the dog started salivating just after hearing the bell, even if the food was not given to him, as the dog was reinforced that whenever the master will ring the bell, he will get the food. Now let's move on and see how reinforcement learning is applied in the field of banking, healthcare, and retail sector. So starting with the banking sector. In banking sector, reinforcement learning is used to create a next best offer model for a call center by building a predictive model that learns over time as user accept or reject offer made by the sales staff. Fine. Now in healthcare sector, it is used to allocate the scarce medical resources to handle different type of ER cases by building a Markov decision process that learns treatment strategies for each type of ER case. Next and the last comes the retail sector. So let's see how reinforcement learning is applied to retail sector. In retail sector, it can be used to reduce excess stock with dynamic pricing by building a dynamic pricing model that adjusts the price based on customer response to the offers. I hope by now you have attained some understanding of what is machine learning and you are ready to move ahead. If you like this video, stay tuned for my next machine learning tutorial, and yes, don't forget to hit the bell icon and subscribe yourself for our upcoming tutorial series. Before I end this video, if you have any confusion regarding the topic, you can add your query to the comment section. Thank you.
I hope you have enjoyed listening to this video. Please be kind enough to like it, and you can comment any of your doubts and queries, and we will reply them at the earliest. Do look out for more videos in our playlist and subscribe to Edureka channel to learn more. Happy learning!